got that one done.
I'll wait over there.
So my slides look boring, so I'll add some cooler text. If you know, you know. Comic Sans is the best. So I needed some GIFs, so some more action in those slides. Some pictures. So one I like to use a lot if you ever work with me is the man shouts at cloud. Thought it was funny, The Simpsons at the time, and it's more relevant in my life now than it even was then. And then voice inflection. If you ever want to know how to talk about things, this is one of my favorite TED Talks. It's Will Steffens, How to Sound Smart in Your TED Talk. And he just walks on stage for about 15 minutes talking about literally nothing but how to talk and sound smart. And with that, finish the talk. Cool. Thanks for coming. We can go ahead and wrap it up. Thanks, Farm Credit, for having us. We all got some good pizza. But really, we're all into the real reason we're all here today, talking about bicep versus arm. So I think to kind of level set, we want to talk about, we all know a little bit about bicep, a little bit about arm. What are they? Why do we even care? So the reason we want to use either of these solutions is for infrastructure as code. If you're unfamiliar with that, it's basically documenting our infrastructure in some sort of language, so then we're able to reference back to it without having to go through and click through a bunch of control panels. We can easily redeploy it in the case of a disaster situation where something goes down. It's self-documenting at that point. So it's not, what did somebody click on a control screen? It's assuming nobody can touch your cloud. I can go to the config file and see exactly how this is set up if I want to replicate it, n times in every environment. So with that, it helps reduce management overhead. So when you just want to spin up a new environment, assuming everything is documented in infrastructure as code, it's as simple as I pointed to this resource group, I'm going to point to another one, and I should have a mirror match of what I just did, assuming everything's in code. You can do pipeline validators like Template Test Toolkit or PS Rule. Those both are newer tools coming out that can work both for ARM and Bicep. So you can go through and you can actually write pipeline validators to make sure people are following whatever standards your organization comes up with. PS Rule allows you to actually write custom validators. So you can write whatever you want as an organization to decide your standard is in Bicep. And you can make sure, kind of like linters with everything else, that it meets whatever your organization is setting as a standard. We touched on self-documenting infrastructure. So instead of just going through a UI and trying to click around and see how everything works, you have all that there with you. It's redeployable and you can use orchestration. So if it goes down at 2 a.m., the guy who is your main DevOps person hopefully doesn't need to be on. It's just whoever has access and can then easily just hit the go again button or whatever. And sorry, the Zoom window's annoying. The faster speed and consistency, and you can more easily use code reuse. So with modules coming out in Bicep and shared templates in ARM, you can then build a solution once, and then when you need to spin up another project team that needs similar infrastructure, you can easily then expand that throughout your organization. So you're not sitting there reinventing the wheel, as developers tend to like to do every single time you spin up a new project. So that way, each new developer can maybe help polish the thing you have instead of reinventing the wheel of, how do I get a VNet to connect to my on-premise stuff? It's instead just pick this up and like, oh, maybe there's a way I can simplify this thing. Every person is then helping, make the solution a little better instead of having 15 different things that somebody someday is going to have to support. So I do have a question. For compare and contrast here, what do these two things kind of have similar and what do they have different? Feel free to shout them out or just raise it. Go ahead.
Wheels.
Wheels? Yep.
They're expensive.
Yeah.
Well, less transportation.
Yep. I think those are all great observations here. So one thing behind the scenes that you may or may not know is they both have Rolls-Royce engines. So how this relates to ARM versus Bicep, I kind of look at it between a car and a plane, right? ARM was built as the first mechanism to kind of get your code through infrastructure as code up into the cloud. That's like your cars, right? People invented cars to get from point A to point B. They were a little clunky at first, slowly getting better and better and iterating on that. And then somebody looked at that and said, what if we design this even better? Take all the shortcomings of a car, all the shortcomings of ARM, and then developed Bicep. So when you're trying to compare ARM versus Bicep, I kind of look at it as like you're comparing transportation by car versus transportation by air. They both work. They both have great use cases. But when you're really truly looking at one and trying to improve on it in every aspect, like a plane is faster. If you have your own private jet, it's quicker because you just go and you hop in for longer distances. You then probably have a private pilot. You can just go and just be up and gone. Well, a car will still get your organization where it needs to be. It just might not be as quick, might feel a little clunkier, might not get you there as quickly. So some of the things we have here are kind of pros and cons. Readability. Again, since Bicep was trying to improve on everything of ARM, it's written in a more syntactual programming language instead of JSON, which JSON is more kind of built for machines and less for people. So they get very verbose and are kind of hard to read. The maintainability, I believe Bicep has a few different ways to make it more modular and make it more readable, and also has more linters and helpful extensions to help autocomplete. So I think maintainability does help you a little bit there as well. If you're really a big fan of JSON, that would lead you more towards ARM. It's one less programming, one less domain-specific language that you have to learn, which is another pro for ARM. And then linter support is something that Bicep has out of the box. So we'll go ahead and pull up here an ARM example. I thought I had it open. Maybe I don't. Oh, just 1 second here. I thought I had these both open.
By the time you pick it up, I can share one trivia. So when ARM came up, people really loved it. But as the deployment sizes started growing up, the ARM's template sizes was growing like anything. That's when Microsoft came up with an idea of having their own language that simplifies the overall process. And then there were numerous surveys that were done. What should be the new language? And how they selected Bicep was because ARM is literally a human arm. And then they were looking for how will you strengthen the overall deployment processes. When someone really picks up weights, they build up their bicep. So that's how they ended up choosing Bicep as the language.
It's the extension of the ARM. So here's an example of an ARM template. What this is doing is deploying a Azure server farm to then host an app service and an Azure function, and tying all of those things together. At the time of writing, it was syntactually correct. It might not be anymore. And since then, there is some new JSON highlighting that makes it look a little bit more readable and easier to work with. But at the end of the day, we're still at 162 lines of code here. There's a lot of stuff that also is included in JSON that you have to explicitly specify that you don't always have to do in Bicep. Just as another one of those things is they're polishing stuff and cleaning it up. So as you can see, it's a little bit basic. It is JSON and it's computer language. It's meant to tell the servers up in the cloud what exactly you want, how to provision it, not necessarily something you'd go and send your buddy and be like, oh, look at this cool thing I just wrote. They'd be like, what is this garbage? It's so much. So the drawbacks are long lines. Some people have love and hate relationships with JSON itself. I'm fairly indifferent. I don't think it's quite the deal breaker. I think the harder part is getting JSON to work in such a way that you can then make it human readable is a little difficult. So we have a bicep example doing the same thing. So again, this is probably more similar to kind of a programming language that you use. You have your parameters, which in both ARM and bicep are what you pass in. You can set defaults for them. So a parameter is intended to be overridable, but you can set default values to take in. You can have secure strings. So if you want to pass in something that's a little more secret, you can put a secure annotation. You can have variables if you want to do string interpolation and combine different variables or parameters up above. And then what I like is the declaring the resources. So you can go ahead and type, let's see if it'll autocomplete for me. Sometimes it doesn't do this. Typically, if my extent, there we go. So one thing that's really nice about Bicep is as you start getting more and more resources, it will start trying to autocomplete what you're doing. So when I do .storage, it'll actually help me go, okay, what was I trying to do? What is the API version of that? And I'm done. Whereas if you're doing that in ARM, you're going to have to go out, pull out the docs, type it out, make sure you figure out what exact API version it's on. Because Microsoft's Microsoft and they're a huge organization, their APIs don't also fall on the same dates. So depending on the resource, depending on exactly what you're trying to deploy, those dates are always going to be a little different. Some are touched more often than others, so they're going to be more frequently new and out-of-date versions, whereas Bicep helps you with that. The other thing is if you delete things that are required, sometimes, I don't know if anybody's ever done this before, when you go ahead and deploy something, you, with ARM, a lot of times in my experience, wait until you get to the point of deployment to say, oh, that parameter that maybe in the docs was marked as optional, but the way you've configured it, it is not. Wait till you get up there before you find out that something's broken. One thing that Bicep does, and it's ever learning and expanding, it is by no means perfect, but it will tell you that this required resource is missing the property of location and name, which is required. And then it tells you a link of, hey, if you have a problem with the documentation, please open a pull request and fix it. So I think the biggest time I've seen this fall a little flat was working with Azure Container Apps. And it was just the minimum SKU is like 0.25 gigs of RAM. And it was telling me that it required a string instead of an integer or instead of a decimal. And it got a little upset about that when there really was a smaller valid SKU. I just didn't want to pay for that much. And opened up a PR. People saw it, resolved it. And it's very active. I commented on the Git issue, and I get emails every day, and that now goes to its own specials folder in my inbox. The other thing you can do, which is kind of cool, is you can put comments in here. So we talked about how infrastructure can be self-documenting. Well, this way you can be even more explicit. So if you're doing some crazy stuff for some reason, like maybe a business requirement, or maybe with the way your on-prem infrastructure is, you just have to do something that maybe out of the box isn't super self-explanatory. You can come in here with a multi-line comment and say like, hey, I'm going to do this thing and this is why I'm doing it. And maybe if you have a better idea, here's all the ramifications of why we're doing it this way. Feel free to fix it later, but here's what I'm doing. You can also reference things directly like you would a variable. So the reason this one's actually upset is because Bicep does have some things behind the scenes as well. So it's saying that this depends on for a server farm isn't necessary, because in order to have a web app, which is an app service, you obviously need a server farm to run it on. So it's like you don't need to explicitly say it's dependent. It's implicitly dependent. We can't deploy a server without a server farm. But if that same line in ARM here looks like this. So again, it's not terrible. I've seen some of these get really gross if you're starting to do really long things and starting to do a lot of referring back to things. However, this is how you would do the same thing as just this. And then it also is smart enough to say, you don't actually need to do this. There's also some general Bicep rules here, like your location. It wants you to deploy all of your resources as a global parameter so that you can override it if you want to. but that way it's set the same for everything. That way you don't have some resources deployed, say in East US, some in Central US. There's some implicit, depending on how those things are connected, latency there. So it tries to help you hold your hand a little bit and say like, hey, do you really want to be hard coding these to different locations, different regions? And then if you look here, in ARM at the time of writing this, there was these two different settings that were required in order for an ARM template for an Azure function to deploy. Everywhere I found online was basically like, yeah, we don't know why these are set here either when they're always this value to deploy an Azure function, but that's the way the cookie crumbles with ARM, sorry. Whereas Bicep was just, they're always set to this, they're always gonna be this, we're just gonna hide it from the user. And those are little things that I think they're improving on with Bicep of, do I care that the web content share is set? Do I care that the website run from package is true? Like, those things are always gonna be true if you're gonna be using the way you're deploying stuff. If it's not, you know why it's not, and you need to go in there and explicitly say it. But for 90% of the people who are using it out of the box the way it's intended, don't really need it. There's some things like that in Bicep that they continue to improve on. Go back to here. And Microsoft has also kind of said that Bicep is where they're investing their time. It's where they're kind of going in the future. I don't believe ARM will go away because Bicep is turned into ARM before it's deployed. And we'll show that here in a working example. But they're spending a lot of time and resources to try to make their infrastructure as code as human readable, as easy to use out of the box as they can. So it's a lot of what their new features are talking about is how to use Bicep, a lot of those things. So it's kind of where they're focusing and kind of where they're pushing people. I believe at the time of writing this, Bicep was still not fully released in V1. Let me check. They were getting ready for it, but I don't think. They're still not in V1 full release at this point. So there's some issues with that. Like I said, with the newer resources aren't always fully fleshed out. Some things to be said there. Yeah. And then it's also a domain specific language. So like, even though technically it is similar to some languages we might be using, it is not C# out of the box. It is not JavaScript out of the box. It is a domain specific language that you're going to be learning just to deploy to Azure. There is some overhead to that. And then you as an organization need to ask, is the domain specific part of it, is that leap worth it enough to not have to write JSON or try to track down JSON? I think that's the biggest question you would have. Side by side, we can pull up some of these. So I did have a really in-depth side-by-side example here until Microsoft came out with this in the Bicep Playground. Both are pretty sweet tools if you ever want to convert yours from one to the other. And they'll show, I think on average, they're saying that once you start getting out there and getting a long file, you're looking at probably about half the lines for ARM versus Bicep. So your file sizes end up being a lot smaller. A lot of their expressions are less verbose for Bicep, so it just is a little easier to use. For example, like how we pointed out, your parameters, this is the Bicep format, this is the JSON format, and all of those sort of things. There's just a lot of different reasons they show one over the other. And especially if you start doing some logical operators or doing like for loops or whatnot, JSON just gets really gross really quick. But yeah, this is out here. The other thing you can do is there's a thing called the Bicep Playground. You can actually look at sample templates. They have a lot of these. So if you're ever doing anything at your organization and you want a out-of-the-box example from Microsoft, there's a lot of them in here. And it'll also show you the difference between the two. So if let's find one that somebody might do. So this is a VM with a front door private link. We got the Bicep and the ARM. Hopefully will load. compilation failed. Nice. Testing in production. The other thing we didn't talk about either is descriptors. So if you want to specifically talk about what inputs are, you can do that as well in Bicep. But I swear this worked before. Let's try a different one. Let's try this. Yeah, there we go. So if you look on the left, what did we end up picking? I don't remember. So this is a storage file share. So on the left, is it in Bicep? On the right, is it in ARM? You can see it's a lot smaller. You can also add validators here too to your parameters if you want to blow up on input of improper input. And then that real example we showed here. Again, this is just an app service deployment with an Azure function. We can go side by side. I'm in a real world example, and this is with a bunch of comments too, mind you. We're at 103 lines versus 162, where just to show there is no comments in the JSON side. It could have been a little less liberal with the new lines, but I mean, it gets a little hard to see where one line is or not. And that's also with, we got 3 lines of comments there. Got another like 6 there, 7-ish. So as you can see, it's about half the size-ish, give or take. Yeah. So what does this mean to you? If you're in ARM today, are you just completely doomed? If you decide you went to Bicep and it was a horrible decision that you never want to talk about ever again, it totally does not matter. So there's actually tools, like I said, because Bicep actually compiles down to ARM before it's actually applied in the cloud, it's actually pretty simple, use that in air quotes, pretty simple to convert from one to the other. Obviously, it's not going to work 100% like right out of the box. Depending on which way you're going, you might get a little bit of boilerplate. There might be parts of your template that don't quite convert one-to-one because you might be doing some stuff that maybe is a little too advanced for the system, but you can actually decompile your Bicep here, and that's what this is doing, decompiling a Bicep file to ARM. So if you just are curious what Microsoft does with your Bicep behind the scenes, you can totally have it dump it out and it'll show you. And then it'll talk about some conversion issues that are common. And I believe there's a line right here. It's Bicep decompile. There's a way to also migrate it with the Bicep playground, I believe, to get it to Bicep. If it's not super crazy, you can copy and paste on one side your Bicep and it'll try to convert it to ARM, and your ARM and it'll try to convert it to Bicep. Doesn't always work 100% of the time, I think, with everything, but you can start taking chunks of your files out if you are able to go through and identify which pieces are the part that are breaking you, and you can start to redo it piece by piece if you want to, or write it piece by piece. And then it's not a closing door. Go ahead.
I think it is extremely useful for organizations who have lots of ARM templates already built up in their repositories over the years.
Yeah.
If they want to convert into Bicep or vice versa.
That's a great point. And it's a revolving door. I think that's the biggest decision point too that I like to make when I'm talking about technology is like, if I adopt this, am I stuck with whatever I adopted? Because you can compile it back down to ARM. If you decide you went to Bicep and you want to go back because that's where your organization is, people were frustrated, you can go back. It's not a shut door. Microsoft's going to have to keep maintaining it because ultimately the part that communicates with the API is JSON. So you'll always have that support, at least as far as we can tell, right? So that's what I got for the slide deck. If you're like me, I'm always like, that's well and good. I love hearing about technology, but how do I actually use this? Like, why do I care? So I do have a little bit of a working example here of doing something simple. So go ahead and I'll close out of all this. So I'm going to have a simple application here. It's just the Angular Tour of Heroes app. And we were going to build, we'll use some GitHub actions and build a pipeline and then a bicep file to deploy it. Just because whenever I learn something new, that's the first thing I'm always trying to do is, how do I use this? What's something I can do with it? So I'll go ahead and do sample.bicep. And you'll notice I do have the bicep extension. So it's going to try to help me. As with any linter, sometimes it's less than ideal. There's also types in both bicep and arm, but we can go through here. And then if you saw my last one where I was setting the location, this is what it wants you to do. So it actually wants you to reference your resource group, which is a function, and then grab the location, which there's a lot of other helpers for this in ARM. It's nice to have it all right here so you can easily go. I'm going to go and just grab it. So what that's saying is I want you to go with your file. So wherever my resource group is, I want you to set that to the location. So that way my resource group and my locations are together. You can technically split them apart. I don't think there's really a good reason to do that unless there is a particular region that doesn't have whatever technology you're trying to use. So for example, I believe Azure Static Sites, which is what we'll be deploying today, I don't believe allows you to host static sites in like US East, for example. So obviously that particular resource, if your resource group is in US East, sorry, you're out of luck, it's just not there. Microsoft also, when they roll out new features, they tend to do it region by region. So like US East, I believe, I don't know if it's the case anymore because there's a lot of people in US East, but they roll them out region by region. So they'll sometimes roll out like their GA, which they call general availability in a particular region or a couple in a country, and then it trickles down to the rest of them just in case there's any big issues, unforeseen things like bringing down the entire network. They won't bring down all of their Azure infrastructure all at once. So we have our parameter, which will be our location. We're going to declare our resource, which is going to be called static site. And then here's my extension trying to help me. It's a Microsoft Web. I also think this example works well. I like to talk about how you can use Azure for free, or at least get comfortable without having to spend a bunch of money. Static sites, I can show you the bill I pay for it. I think on my personal site, there's an asterisk by free because technically you pay for blob storage, but unless you're hosting something crazy, Microsoft rounds it down. There's the asterisk there though, so if you start doing some crazy stuff, I am not responsible. But this is just the sample out of the box Angular Tour of Heroes application we're going to be deploying. Go ahead and look here. Looks like the specified resource needs a location and a name. So go ahead and tell it to do the required properties for me. The location I'm going to set to the location above. My name, we're going to call it test site. And then, just because I like to be overly careful whenever it comes to the cloud, I'm going to specify the SKU. Sometimes Microsoft will, especially like in app services, they default to standard when there is cheaper options like development or whatnot. So whenever possible, I do try to explicitly say when possible exactly what tier I'm trying to get out of something. Just a pro tip if you're trying to save money or if you're on your own Azure subscription and trying to not pay for it. So the tier in the name is free. You can have 2 free static sites per, I believe, subscription. And there's some caveats there where I think if you get enough requests and enough throughput where these 10 gigabytes of throughput, they will turn it off. But if you do want to go to the paid version, which is kind of unlimited, it's $10 a month. So for what I use my personal sites for and whatnot, this is more than sufficient. And then we're also going to need to output the deployment token. And that output's going to be a string because we're going to reference it in our Bicep file, or sorry, in our GitHub Actions file. With secrets, that takes the resource ID. So we're going to do static site.id, the API version, which is going to be static site.api version. And then because it's a static site, this is where it doesn't quite help you anymore, but we know we're going to have the API key. And if you are going to use this on your own, GitHub Actions is a little bit more secure than Azure DevOps, I've noticed. It actually will not allow you to proceed forward by outputting a deployment key. It will blow up and tell you that that's not super secure, you shouldn't do that, because this is a sample case. Really, you should probably be putting it in Key Vault and accessing it there, because this is just a sample whip application. You can override that functionality in GitHub Actions, which is disable next line. Outputs should not contain secrets. So you can tell GitHub Actions, I hear you, I don't care. And then they can say, cool, that's your fault if your password gets compromised. And then so that's it. That's all you need for a free static site hosted in Azure. We'll go ahead and write the deployment pipeline for that. It should not take too long. Which we'll go ahead and, if you've never used GitHub Actions before, kind of the standard place to put it in is .github and then workflow and then pipeline.yaml. So we're going to declare what we want this to run on. So on is like, do you want it to be on pushes? Do you want it to be on pull requests? So if you want to run your test suites, you typically want those to run on pull requests. If you want it to run on everything, you can do it on pushes. So because I'm being a bad developer, I actually just want this to only run on pushes to my main branch. So that means this will always run whenever the main branch is touched. If there's pull requests, it won't do anything. And then we'll need to give it permissions, ID token, and we're going to give it a write, and then content read. If you're curious about this, this is to allow our GitHub Actions to get a SAS token to our Azure instance, and then have that token and be able to use it to read the values in it, to be able to hit Azure's API and allow us to do basically login. We'll eventually have our static site Bicep deploy, and then we'll deploy the code itself. So we're going to declare our first job. We'll call it build. Runs on. I think Microsoft came out with an article a year or two ago that talking and typing is hard. That most of their servers in Azure actually run Linux, which is kind of interesting. And a lot of JavaScript stuff tends to run a little quicker on Linux. So we'll go ahead and do that. The steps are what we're going to tell it to do. So we're going to first use actions for GitHub Actions. Check out at v2. So this is giving our pipeline access to our code repository, so it can then check out the code and read our Bicep file, read the Azure Tour of Heroes project, all that sort of fun jazz. And then we will do uses. We need to then get connected to our Azure instance. So log in at v1. If you're curious on how to do that, you can Google it. There's a walkthrough of exactly how to do that, how to generate a token that you can then use to connect. It's pretty simple. It's just one CLI command. And then you copy that into your GitHub secrets. So I won't share my secrets with you, but we're going to connect to Azure login with creds. And it's going to be what I named it. the wrong. And this name is totally whatever you want it to be. So I named mine Azure Credentials. And then we'll do enable AZP. All right. So now after this, we will have our connection to Azure established. We can talk to it, communicate, do what we need to do. So the next step we're going to do is give it a name, which will be the run bicep deploy. And then we're going to give it an ID because we'll need to reference this step further down. Oops, there should be a tab, not a space. And this is the ID is going to be used to reference that output variable we have to reference it later in the script or in the pipeline. And then we're going to use is, and this is where it's very obvious that Azure uses ARM to deploy bicep files. So the step, even though we're using bicep, you're still going to use the ARM task, skill, whatever you want to call it. And behind the scenes, it'll actually convert it to ARM for you and then ship it off to Azure. And then we need to tell it where we put our file. So we're going to do template. That's going to be /sample.bicep. And then we need to give it the credentials. I'm just going to steal these from up here because they should be the same credentials. And then we're going to say, give it the resource group name so it knows where we're expecting it to deploy these. I pulled that out to a variable just because if I want to use this for like n environments, it's nice to be able to pull that out to a variable. So then when you're deploying each of your environments, you can look at maybe an env setting or config to make that reusable for like a prod and non-prod or however you would like to do that. So since that's a variable, to Azure user dot bicep. So with that done, our infrastructure should be done. And then for the final piece of this, well, second to last, we're going to use static Azure static web apps deploy at v1, and that will be with, and this is where we need that output we listed before. We need Azure static web apps API token. And we'll reference that from our bicep file. So we need to first get to the outputs of our bicep file, which will be steps, which is what we did up here. So right here, we tell it to go look at the steps. We did the ID of deploy. So that was this up here, right there. And then we gave it the name of deployment token, right? Just in case I spelled weird. All right, and that'll pass that to there. Repo token, because we need it to be able to get to our repository and actually get the static site that or the Angular app that we want to use. GitHub token. We want the action, which is going to be upload in this case. Sorry, double quotes. app location, which is ./Angular tour of heroes. And the artifact location, it'll look at this and run your npm command for how to build and publish this. And if you've worked with Angular apps before, it likes to throw it out of the box in dist, and then Angular tour of heroes. And then best practice, I don't think it really matters. If you trust the people who are running your code, you maybe don't need to do this, but best practice is to run az logout. So what that should do is close your session to Azure. So if you trust the place you're running your code, maybe you don't need it. It's just best practices. That way, if you're done, your connection can't be intercepted and then deployed and cost you a bunch of money. So like the cooking channel, it's to come with a pre-baked thing here. So if we go ahead and look at the actions, we can see we have our build step that we specified over here. We go through here. We have our building the static site. We're running the GitHub checkout action to look at the code. We're doing our login, which was the next thing. We're doing our CLI command, which was, we'll get back to that. Running bicep deploy, unexpected input credentials, which is fine. I don't think we actually need the credentials step. That might be a miss, sorry. We already have that connection established, so we don't need to feed it credentials again. Build and deploy. It'll actually go through here and tell you all the steps of deploying it and give you a link. And then our logout, so nothing can touch it again. There is one minor thing here. If you want to deploy static sites in a CI/CD environment, you will need this command right here. Basically, when you deploy your static site, kind of holds that connection tight, won't let anything happen to it. So if you try to redeploy like a second time, it'll tell you that site's basically busy. You can't redeploy it. So with this simple command, it'll disconnect it, allow you to redeploy it, put it back up. With Azure CDN, typically you do not notice a downtime by doing this. But if your deployment takes a lot of time, if you hit it just right, your mileage may vary. But what I've noticed in our apps that we've done this before at a previous job is our end users didn't notice any outages. There's also environments in static sites too, if you go to the paid version, so you can do the whole, kind of like you do with app services, where you can do swapping between different instances, so you don't have to worry about that. But this is my personal website too. Probably nobody's looking at it, and if it goes down for a millisecond, chances statistically speaking that anybody notices, probably 0. And with that, we'll go here to Azure. We have our resource group. Let's go back. So here's our test resource group, our test site. The other thing that's nice about Azure Static Sites, if you have a user base that is okay with just bookmarking stuff, you'll get a free HTTPS cert, so they can communicate over that. And that's the site we just built. Anybody have any questions? Go for it.
Is there any functionality built into Bicep to like show the output of what it's going to do before you actually deploy it?
You're talking about like the ARM validate command?
Yeah.
I believe so. I think it's called what if. Yeah. You can preview changes that'll happen before. Yeah, and then it'll have an output kind of like this. So that way, if you're doing something crazy, it should hopefully help you there. But yeah, good question. Go for it.
A few questions. Does Microsoft publishes anywhere roadmap of Bicep, including like which services are currently supported and which ones are coming up? I mean, I remember you were saying not all services are supported. That's one of the downsides.
I believe all of their resources that are in GA are supported by Bicep because it is ARM. It's just the linter. I don't know if it's still a thing. Specifically, let me go here. They are all supported. There was just let me check if it's fixed. I think that's still in preview. Let's see. Location, and I think it was the SKU. So all of their new stuff, all their stuff that comes out for the cloud is pretty much supported in Bicep. It's just the linter rules might tell you you're doing something wrong when maybe you're not. So for example, for the SKU for an Azure container app, it goes down to 0.25 gigs of RAM for the server, like the instance that it's running on. Everything greater than that's like 1, 2, 3, up to however much you want to pay. So for example, 0.25, it was telling me it was expecting an integer and I was giving it a decimal and it freaked out. So it worked. I can say disable this next line and I believe GitHub Actions also doesn't really care. It's more of like a, hey, by the way, because when it does get compiled to ARM, it still knows 0.25 is valid. It's just whoever wrote the syntactual extension just had a miss there. So they all work. It's just sometimes you don't get the linter support that you would. But again, the alternative is none in ARM. So.
And linter support is through an extension and we just report.
Correct. I can pull that up. Sorry. It's this one.
With any client that I work with, when I recommend Bicep, one of the common question is, why should we go with Bicep and not something like Terraform?
Maybe I'm a little bit biased. I don't like Terraform personally because when it was released to the market, it was sold as a cloud agnostic language to deploy your code. And I believe, at least when I walked away first hearing about it was you could then pick up your infrastructure, drop it in any cloud. Theoretically, if you wanted to play the game, go from AWS to Azure to Google and have like no impact on anything. As soon as you get even like remotely into Terraform, you are writing specific stuff for Azure, you're writing specific stuff for GCP, you're writing stuff for AWS. That's where like the marketing to me feels a little sleazy personally, is because they'll go to like high level execs and say, hey man, you can pick up and drop this off in any cloud that you want. And they buy it, right? Because it looks like it does, until where the rubber meets the road. And it's like, well, you're writing specific logic for GCP, you're writing specific logic for Azure. You're also having that fall behind potentially too of the latest and greatest features are going to come to CloudFormation and Bicep and ARM before they come to Terraform, just because of the way the world works, right? Your first party language support's always going to be, even if Terraform is right at the heels, they're not directly developed by Microsoft or Amazon, so they're not going to be, or Google, they're not going to be quite in step. Again, your delay might not be noticeable, right? Like as an organization, you might not be doing bleeding edge cloud computing. So maybe you don't care about Azure container apps. Maybe you don't care about quantum computing, whatever the latest, greatest thing in the cloud is. Maybe it's not something for you, but that's where, I don't know, the message kind of rubs me wrong. So I've always kind of like shied away from that a little bit personally, but there's also state in Terraform, whereas ARM and Bicep can be stateless.
I believe whatever you're shown using GitHub Actions, we should be able to pretty much using Azure DevOps.
Yes. Yep. The steps are called something slightly different, but yeah, they're YAML. If you're doing the legacy pipelines too, you can click through and there's pictures. So like you don't even have to fill out all of the YAML. It has a lot of pre-filled stuff for you. They're trying to move away from that, but while it's there, it's cool. Saves you a lot of just boilerplate. You just plug in what you care about.
Is Terraform free to use or is it vendor thing?
Terraform is free to use unless you want them to manage your state for you. Then they'll charge you. I don't know. That's personal use. I don't know if Enterprise, they have a license or not. Do you know?
I think they have a Terraform for enterprise license, but it comes with the support plan.
In Bicep's file, you use parameters and variables.
Mm-hmm.
How do you use the environment variables for different environments? For example, in ARM, we generally have separate files to call the parameters from the file.
Yeah.
Is something similar?
Yeah. So the parameters you can pass in either through a CLI or you can pass in a parameters file in Bicep as well, the same way you would do it. So you can have a parameter file similar to this, and then when you go define it, it should have an action step when you go and actually use it.
Parameters, I believe, can be inline or it could be in separate file.
Yeah. So you could one-off say, here's the parameter. So for example, I did location. If you have a deployment that's going to a particular location, you could override it line by line, or as the example there, if you want to say, look at this file completely, same thing.
And you can handle replacement of these variables through environment variables through your pipelines or actions as well.
Mm-hmm.
With your YAML file, do you use any VS Code extension for like formatting your YAML files or validating YAML personally?
That's a good question. I don't believe so.
I believe there is an extension for ARM and there is an extension for YAML as well.
There's a
The one I could use is like maybe Azure pipelines.
So there is one extension called Azure, which comes with most of the basic Azure tools. This for website hosting. I think it's the
CLI. Azure Tools is pretty cool if you've never used it. It's like if you've ever deployed your code via Visual Studio, like on that sidebar, it lets you do that for VS Code. So you can go here and see like your resources and all that and deploy directly to them from VS Code if you don't want to pay for Visual Studio, which is pretty cool. YAML support.
For YAML, there is an extension from Red Hat. But I think it's generic, it's just not specific to Azure ARM templates.
I'm trying to figure out this task in Azure. I'm doing something because I'm getting some sort of like, unless that's just out of the box VS Code, which maybe it is. I don't know.
I've just ran into the problem in the past where like, yeah, you build out a YAML file and then go to run it and it's like the tabbing's wrong.
You don't have quite the right amount of white space, so you have just a little bit too much white space. Yeah, that's why. Love YAML. Yet another markdown language. Any other questions?
I thought you mentioned modules earlier on. Is that possible with Bicep? So could I create like a storage account module and then reference that from like multiple other application deployments?
Yep. So I believe in ARM templates, they're called shared templates. In Bicep, they're called modules, and they're stored in your container in repository, I believe, in Azure. But as long as the resources have read writes to it, you can do that and share it between however many you want. One thing I've
you can just refer to other bicep files from main bicep file.
Correct. One thing I've seen companies do that for in ARM and Bicep specifically is like SQL servers. So they might have a very robust security standards on their SQL servers of like maybe only these allowed IPs, these allowed subnets. So for everybody who's deploying a SQL server, the organization makes it that you have to use that. And then that way, as a developer, I don't care, right? Like I'm using a machine from my client. So it's like, yeah, it works because it's allowed to hit that. But then the security team's also satisfied because they know those IP ranges are going to be locked down. And it's kind of the best of both worlds.
Yeah, that's one of the reasons in the past, at least, most of the organizations I've worked with have tended towards Terraform, just because that functionality was always built in. Because I think like 2 or 3 years ago, you couldn't do that with ARM templates. I guess that's changed. So.
Yeah, and it's not, you can do it in ARM. It's okay. They're trying to make it better, and I agree. Like a couple years ago, it was even worse. Like it's good now, but yeah, I think to your point, Terraform has had that kind of out of the box. It's pretty good now. That's where your descriptors and your validators come into in Bicep. So if somebody's trying to pass you an invalid name or trying to figure out what a field is used for, they can get a cleaner exception message or a clearer validation error of why they screwed something up. Comes in handy, pretty cool.
I've seen in several places in documentation. Earlier, they only used to give ARM templates as the example, but they are also including now Bicep templates as well. I know in Azure Portal, if you have resources, you can export ARM template.
Mm-hmm.
Did they also include Bicep templates there now? Do they have any plans?
That's a good question. Last I looked, I want to say no.
Because essentially, as you said, under the hood, it transforms into an ARM template before it does the deployment.
Right. Oh, let me remember where that is.
You have to go to resource group, I think.
We showed us that converter ARM to Bicep, just exported to ARM.
Yeah, so it does give you it back in ARM, which is funny because that's what we just, and there's a bunch of properties here that we didn't specify. If I download it, does it give me the option? No. Looks like
because
it's.
they want you to run that CLI command.
Yeah. Yeah, it doesn't look like it does.
That Bicep Playground is like a open source thing or Microsoft?
I believe it's run by Microsoft. I could be wrong there though.
It runs in Azure.
Yeah, it runs in Azure, but the URL does not look like a.
I think it would be from community.
But it's.
Yeah, I've seen that number change a couple times as they iterate on it. I don't know who owns it or.
But that is Windows.NET.
It might be their internal tool that they just made public. So that people can use it.
Yeah, the other thing is they build a lot of tools for like I think they're called cloud solution architects to come out when they're trying to help clients and whatnot. And I'm wondering, to your point, this might be an internal tool they built to help sell Bicep. And then they're like, well, why don't we just let anybody look at it? There's nothing like proprietary here. It's just a simple template, or some of these are complex, but just showing a sample one on the left, sample one on the right. Nothing too proprietary.
So I was once joking with the cloud solution architect at Microsoft. He was saying there are thousands of tools that Microsoft uses internally to do stuff that's not possible on Azure or any other Microsoft tooling. That's because they keep it that way so that people still keep buying their support. Keep paying for their. I think this would be an internal tool.
Yeah, and I mean it's on their documentation. So one of their cloud solution architects was the first person to show me about it, and I'm like, is this something that I know it's a public facing URL. Is this something I can tell people about? Because he helps me run the Des Moines user group. He's like, oh yeah, show everybody. And then it started showing up on more and more documentation. So I'm like, okay, we're good here. I'm like, I don't want to get you in trouble because it's not a short list to be like, who does Alec know at Microsoft? It's like one person. I wonder where he got that from. But yeah. It's cool. We used it at my last client, we had kind of a simple, just like web application that we used in Bicep for deploying an Angular app with a .NET backend and a SQL server, all through managed identities, so we didn't have to have passwords or anything. It worked pretty sweet, especially looking at, they had their first attempt at infrastructure as code was a little rocky. They did it in ARM, had a lot of extra stuff that was like boilerplate because they did the whole, I'm going to deploy it to the UI, I'm going to then download that template and then just shove it in and call it good enough. And like, if you've ever done that, there's a lot of extra stuff Microsoft adds just by downloading that, which, I mean, you can see here. Like, even if I were to write this in ARM, it would not be nearly this verbose. So it's like even worse if you're just going to take this and shove it somewhere, because then it's like, I got even extra junk that if I was writing this by hand, it wouldn't be that bad. But it is easy if you don't want to think about it, because you're just like, we're good. Any other questions?
I'm wondering, logic apps. So it's a big logic app. Logic app ARM template is so huge.
Mm-hmm.
So yeah, maybe the converter might help.
I wonder if they have what is the path for logic apps? They might have a sample one with Bicep. Logic app is Microsoft.logic. Oh, I guess that's pretty, I'll get out of here, Zoom.
Logic apps can take 1 hour session on its own.
I almost got to use Logic apps, and then a previous job I was at, they decided that they really liked Azure Functions instead. And I don't know if that was a blessing or a curse. So here is the Logic app on the left. Here's in Bicep, here's it on the right. I'm assuming that your Logic apps are a little bit more complex than this, but here's just a simple, what it would roughly look like.
That's just defining a resource, is it? But not the actual workflow of the Logic app. I vaguely remember the workflow being like a mess of embedded XML, maybe.
Yeah.
So it has a section for actions down there. So right now it looks like it just have one single action, but depending on your workflow, you might have multiple actions there.
Just trying to see. Sometimes they have arrays too in here that sneak by. There might be. Let's check it out. This I know it's going to be rough. Actions are going to be without color IP. Box there. Yeah, it looks like we're not going to get much more information. Oh, no. It can support arrays for the IP ranges.
Action could be anything, calling an API or sending email or any kind of action in your workflow.
Yeah. It's weird. It's weird that it says the only thing it's telling you about is the control policies, not the actual action itself. Oh, because under accessory controls, is there another actions? No. And then this is, I think, what you were talking about too. A lot of these examples too are starting to have Bicep along with ARM. So if you want to pick one, this is not one of them though. But yeah. If if you want some cool Microsoft points, you can rewrite their stuff in Bicep and people will appreciate it, I think.
Maybe some of those links, they are more descriptive, like for consumption logic app, they say using resource manager template, but then nowhere else they listed it.
It's like they,
Just like the quick start you open for ARM templates, because they're keeping the quick start updated with all new different types of resources. Maybe they might have one for biceps too. I don't know.
It depends on the walkthrough. Some of them do, some of them don't. I think a lot of these are also open source, so it depends on who's gone out there and given what TLC at what time. Because if you look at some of these walkthroughs, there's like this one. I mean, some of these are hyper specific examples, so it's like, oh, I did it once, it's done, it's there. Like somebody didn't go back and change it. Yeah. Yeah, if there's no other questions. Thanks, everybody.